Well, welcome everyone. On behalf of Engineering Tomorrow, it's Betsy Fortman and Milton Davis, and we are just answering some random space questions today. This is session one of us answering random space questions. You all asked a lot of astronaut related questions, so thank God we have Betsy here with Engineering Tomorrow. She is an expert. So I'm Milton Davis, and I've worked at NASA since 2001. And I am definitely more on the space and exploration side. How about you, Betsy?
Okay, so I worked for NASA from like 1995 up to about 2015, 2016 in that time
Sweet.
frame. And most of the time when I was there, I was working in the human aspects of the space station as well as the Russian systems on the space station. Some of the Soyuz launches and landings, and that I was in the exploration branch.
Sweet, sweet. All right, we'll just start running through some random questions. First
Sounds good.
one, is it cold in space? I guess I can take this one.
Sure, sure.
I will say it is cold and it depends. One thing that you'll see, like the closer you are to the sun, that also affects temperature in some regards. But mainly when I've designed spacecraft, what we cared about is whether the satellite was exposed to the sun or whether it was eclipsed. What do I mean by eclipsed? In shadow. So if a satellite is orbiting around a planet, when it is on the dark side of that planet where it's not exposed to the sun, it can be extremely cold, extremely cold. But if it's on the sun side, right, exposed to the sun, it can be extremely hot. And all of that really depends on how close that satellite is to the Earth as well, or to a planet. Some planets have an atmosphere like the Earth that kind of controls the temperature the closer you are to the planet. So, whether you're on the sun side or on the dark side, it's kind of controlled. But once you're outside of that atmosphere, or if the planet doesn't have an atmosphere like Mars, sheesh, it could be really hot or really cold. So yeah, it can be very cold or it can be very hot. Great question. Next question, Betsy, how long does it take to travel in space?
Okay, so it really doesn't take all that long with our rockets in order to get to space. You typically hear our launch cycles, and then when they get to space, there's some cheers that go on in the mission control rooms, of course, making sure that they've made it there safely. But really, the length of time that someone spends in space depends on the mission that they're doing. So when we were doing a lot of our shuttle missions, we were looking at, days to weeks on orbit. But now with the International Space Station, someone might be up on board anywhere from, a few months. Actually, we had someone up there for a year. So it just kind of depends on what your mission is and why you're there, and then how long you would be on orbit for that particular mission.
Oh, that's a great answer. And if you all are looking for like deep space, deeper space, like traveling to Pluto, that takes 9 months for a satellite to get there. So it's a long time. How do you sleep in space, Betsy?
Oh, this is a great question. So in space, of course, we don't have gravity, which, we're used to sleeping on our bed because gravity is pulling us down, right? In space, we don't have that. They have a sleeping bag that they have to actually strap down to something. You'll notice this particular astronaut is actually strapped into what we call a crew compartment, but they can strap themselves anywhere, which is kind of cool because if you imagine yourself floating in space, they can strap themselves to one side of the International Space Station to the other and just be hanging out in up in space. It's really important that our astronauts are strapped down though, because you wouldn't want someone as they're sleeping to go and bump into a computer system or anything else while they're asleep.
Very cool. What's our next question? Oh, what's the main reason to go to space? Man, there are a lot of different reasons. I would personally like to go because it's so cool. But there's some other reasons to go. To investigate and explore things that we've never seen before. There's science, right? There's protecting our planet. Sometimes we'll go into space to investigate things like our atmosphere, things that protect us from the sun, like the magnetosphere, climate, right? Weather. Um, There's also things that you can do in zero gravity, like experiments you can perform in zero or lower gravity that you can't explore on Earth. Um, there are thoughts that one day maybe human beings would live on a different planet. That's a reason to go into space. And there are many different, I'll just say, physics based, quantum physics based, or questions that we want to investigate about our solar system and maybe even other solar systems. And then there's just really cool stuff about just you know, seeing if there's other life out there, right? What I think we'll talk about later on, or comparing our solar system to other solar systems, understanding, you know, what it took for this entire universe to come into being. So there's a lot of different areas: astrophysics, communications, um, there's deep space, um, planetary exploration. There's a lot of different reasons to go, and I can't wait to see what you all are going to do and explore in space as well. Betsy, how many crew members do they have aboard a a shuttle?
Okay, so good question. So if you think about the International Space Station, usually we'll have certain vehicles that will be docked to the different ports. These are the vehicles that the astronauts or cosmonauts would have traveled up to the International Space Station riding aboard. Um, Depends on the actual vehicle itself. So if you're talking about a Soyuz, we can fly up to three crew members on a Soyuz. However, if you're talking about like a SpaceX vehicle, you can have four crew members. And so if you imagine three vehicles docked to the International Space Station, depending on if it's two Soyuz or one SpaceX or one and two, it just depends on the combinations that you could have three, three, and four, 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 and three, etc. So that's why we're kind of limited. You always want the ability to bring your astronauts or cosmonauts back to Earth in the case of an emergency. So we always have a lifeboat vehicle that they came up in to come back down in.
Excellent, man. Sheesh. All right, that's awesome. Great questions too. Then there was a question about the multiverse and string theory. Man, excellent question. So I think we're all kind of familiar with the Big Bang Theory that the Earth, the entire universe was produced out of an infinitely massive but infinitely small point or particle that expanded. And then there's string theory that started to postulate, in some regards, that we live in multiple dimensions, right? We can live in up to 11 dimensions, right? And as part of that, there are some, how do I say this? When you think about quantum physics and quantum mechanics, and you all probably ask this question because you're into studying things like quarks and electrons and, that single point, one-dimensional vibrating string or spring at different frequencies, like in string theory. It does support the potential for multiple universes. And it does support, in some regards, what you all may think of a multiverse. Uh, and this will tie into some of our questions later on. I've always wondered as well, are there multiple universes out there? String theory can support that. Each compactification um, in the string theory produces a different space time. So it's possible that there could be thousands of universes out there, if based on the theory, just based on the theory. Okay, great question. I feel like I would love to have that a longer conversation with you all about that for sure. What's our next question? What types of games do you play in space? You want to answer that one, Betsy?
Sure. So every astronaut has like a limited amount of space that they're allowed to bring up some of their personal items. So our astronauts can actually play music and other things if you're into that. They can also play, of course, if they're interested in ping pong or anything like that. It might be really fun to be able to, ping pong back and forth in the space station when you have no gravity effects pulling the ball down, that it could just keep traveling all the way to the end of the space station. So they have different ways of entertaining themselves while they're on orbit and, just being, having that camaraderie of their group while they're living together in space.
Yeah, yeah, that's very cool. Man, yeah, I would love to play some games with you in space, Betsy. Somehow.
I would too.
Yeah.
Some of the most other ones are like, where they like to eat. They kind of throw M&Ms to each other or whatever,
Yeah.
or spin their tortillas like they're throwing pizzas or something.
Oh, cool. The next question is, what is it like to land? And I think Betsy probably should answer this one, but I would like to talk a little bit about what happens before you land, as gravity is just pulling whatever object down, as it's traveling through our atmosphere, because we have um, molecules in our atmosphere, air molecules in our atmosphere, and it's traveling so fast, it is a lot of friction and turbulence. And friction produces heat. So it's an extreme amount of heat. And these space vehicles have to be designed not just to survive those crazy forces, but the heat is unbearable, right? I think Betsy kind of has a model of like a there it is. And isn't that great part like the heat shield?
Yes,
Yeah.
yes, very
Yeah.
good. So we want to make sure that whatever type of materials that we are putting on the bottom or on our heat shield can withstand some of those like heating and that plasma that happens as we're traveling through the atmosphere back down to Earth. Once we get through that, then our parachutes will typically open up, and it will help kind of slow us down. That's where drag, you remember the forces that we were talking about in our space lab, probably. So that drag can kind of helps us start slowing down. But then again, we have to also be concerned about, the impact angle that we may have as we're hitting the ground. And in some cases, we are actually now landing back in the water, similar to what we did in the Apollo days.
Excellent. Man. All right. Question. Does heat affect air and make it move around violently? Man, you all are asking some deep questions. I can tell maybe some of you are in physics class, and in general, as molecules heat, they move faster, they're moving apart. Um, in general, and you all remember the ideal gas law that PV equals nRT. That also kind of supports that theory about how temperature and volume um, and molecules are impacted. What did you want to speak about, Betsy, in terms of gases and temperature in space?
Great question. Okay, so in order to live in the space station, you have to have, a number of gases like we have our, air to breathe and things like that. So we're always monitoring, how much oxygen is on board, but we also don't want to have too much oxygen because if there is ever a spark or something to that effect, we wouldn't want to, have an explosion. So we have to carefully balance the different gases that are in the International Space Station. Of course, we're also watching for the carbon dioxide as well, because if you have too much carbon dioxide, it can make you really sleepy and then you can actually die. So all of those are monitored, constantly by our mission controllers as well as our astronauts. Um, but when we talk about heating in general, heat, if you think about Earth, we have that thing about heat always rises. We have gravity, and once like it rises and it's, coming back down, we have that convection happening. But in space, we don't have that gravity effect to kind of help that convection process that we're so used to on here on Earth. Instead, what we have to do is use like air movement or airflow in order to transfer heat. So what you will see is we have these fans on the International Space Station that will just basically blow the air through the space station. Um, on the Russian segment, they have certain ones that will blow down the main part, and we also have like kind of the back end of the space station where behind the panels is where all the equipment is. And you can imagine how your computer heats up when it's sitting on your lap if you're traveling somewhere. So we have all of these computers and other equipment behind the panels, and they also need to be cooled. So we have to make sure that our fans are, pushing the air back there as well to transfer some of that heat.
Very cool. Man, I've gotten so wrapped up in this, I forgot where we are. Next question. Oh, are aliens real? What do you think, Betsy? Are
Wow,
aliens
that's a great
real?
question. So my personal opinion, um I have no proof that there are any out there, but I just find it when you think about the vastness of our universe and like you see the pictures from Hubble and the James Webb, aren't they amazing? Like it's so cool. Just find it like odd that we would be the only ones. I have to wonder, is there another place? And so maybe you guys will be the ones to either find life in another area of our universe.
And I agree with you, Betsy. I think it's definitely possible. And sometimes I wonder would I want to meet them or not. I don't know, but I definitely
I
think
know,
I
I know,
definitely think
right?
it's possible. I hope you always hope, hey, if we ever meet some aliens, I hope they're friendly. But yeah, the
Yeah.
universe is so huge. And there's so much that we haven't discovered. And
Hmm.
I wonder if they're thinking just like us. Is there anybody else out there, right? Right.
Right.
Um,
Yeah.
yeah. So then the next question was, will we ever get to go to Mars? And I think for sure we'll get to go there. NASA has several missions that are even Artemis is a step towards it. They have several missions that are preparing us for that. I think we could have been there already, to be honest. I think the technology is here to be able to do it, and I believe it'd be really cool. And some of the things we're doing with in space that has already happened with assembly and manufacturing in space assembly and manufacturing has demonstrated that we have the capability. There's multiple rovers, right, on Mars and even some quadcopters. So we can do it, and maybe your generation, maybe one of you all will be one of the ones to actually live on Mars, which would be crazy cool, crazy cool. Did you want to add anything to that, Betsy?
Yeah. I know that down at Johnson Space Center, they're also they have like this habitat that has been created, and they're actually performing like some missions there to try to, simulate what it would be like on Mars. And I believe they just named the latest crew that will be in there for a year coming up.
We have a couple questions we could go through in the questions from Space Day. Maybe we can hit a couple of those before we wrap up this first session. There we go. Let's just have at it. What classes and experience are most important for students who want to have a career in aeronautical and astronautical engineering? Um, Betsy, did both of us go to Purdue?
Yes, we sure did. Yeah,
Boiler up. We're both Boilermakers.
that's right.
So I'll start with the end. I'll say the four major facets of the aeronautical program were propulsion. There was an area that dealt a lot with guidance, navigation, control, or orbital mechanics. There was kind of the mechanical structures area, and there was one more, aerodynamics, right? When you think
Yep.
about all of those, it's a lot of that is physics. You can see like physics is a core kind of construct that's going to drive almost everything. So if you can find a way to enjoy physics and learn about it, by all means, that's important. And hey, engineering tomorrow, I think almost all of our labs are physics based. So if you want to get the hands-on application, uh, take some more of these labs. How about you, Betsy? What do you think?
Oh, for sure, physics. I would also say math. I mean, I feel like
Yeah,
every class you will take really
yeah,
has some very strong math background in it. And maybe you don't understand all of the different um, areas of the equations, but you can crunch the math and eventually get there. And so I think, having the physics will help you understand what you're doing, and the math will help you get to the answer. So I would say there's a good marriage of those two for sure in almost every engineering class. And that kind of goes down to that last question too.
yeah.
Do people still use math? Oh, absolutely. They use math in all areas. I mean, if you're just running like a back of an envelope, can we do this? Can we make it work? Or a balance of mass of trying to figure out, can we put this particular item on board? our vehicle, and it's going to make it too heavy. Well, then we have to take something else off. What do we take off? How much does it have? Or, knowing the airflow that we were just talking about, how much, power do we have to have behind those fans to make sure we get enough air transfer, that we're getting that heat circulated around and things like that, or getting cool air circulated around. So there's definitely math that goes on.
Cool. Very cool. Um, did you participate on a robotics team or club in high school? You
That
know,
one maybe for you.
I didn't. I think that's one of the reasons why I started robotics club when I got out of high school. My high school, we just didn't have exposure to anything like that. Unfortunately, there was like in my physics class, there was a time where we participated in like the you build the mousetrap car, you know what I mean?
Hmm.
And I
Yeah.
thought that was really, really fun, but I didn't have that kind of exposure. So once I got through high school and then I got through college, I thought, man, I really want to give students exposure to that. And that's why I started a nonprofit called Future Innovative Rising Engineers, which gives students exposure to race cars, robotics, rockets, and just all kind of stuff. So I'm familiar with FIRST Robotics in my program and VEX Robotics. How about you, Betsy?
Oh, this was such a great question because I was not involved in anything like that. We did have Science Olympiad in high school
Oh,
that I
cool.
was able to participate in, but it was similar to kind of your mousetrap car that you were talking about, things like that. Um, and I love, Milton, that you talked about your nonprofit. I think there's so much good in that, and finding something you love and then giving back. And so I challenge you guys, when you find what you love, and you get to where you're going in your careers, see if you can find ways to give back to your communities and to other people that may not have the resources, in their high schools or even middle schools, to help get them inspired and to get them where they are going to eventually go to.
Awesome, awesome. The next question, is it difficult to do robotics every day as part of your job? Like, I would say robotics is difficult. And the nice thing about, I'm on a mission called OSAM 1 or Awesome 1, where we have three robotic arms that we're going to operate to perform the mission. Yeah, robots are really, really hard. But it's a team of us. And that in general makes it a little easier. And that's one thing you can look forward to. I mean, I think some folks think about engineering or think about aerospace engineering. They think, man, this is going to be really difficult. Don't forget, you're going to be operating in teams, right? And the nice thing about operating in teams is you all get to take advantage of the strengths of many different people to solve these diverse problems that we have. Um, maybe we'll do a couple more of these. What do you think about this one, Betsy? What are the key problems of engineering with testing or designing an aircraft?
Oh, this is great. So I think, you had mentioned the four areas that you study for aerospace engineering. And I would say, first of all, that structural loads, knowing how the loads are going to distribute through your spacecraft, whether that's spacecraft or aircraft, being able to kind of predict how much fuel you're going to need, things like that. And then actually testing it. So testing, it's one of those things where you can test, and never actually launch. So you need this balance of testing the really important factors, making sure you got those down good, and then knowing when it's time to go ahead and do a real flight test at that point.
And that's a great answer, Bessie. You almost did a great like intro to why they should take our aerospace lab, right?
You're right. You're right.
Man, that was great. Yeah, she did a promo, so now you got to do it. You got to do it. I can't wait till we start designing. Like people have started designing supersonic aircraft, but one day they're going to design aircraft that can go the speed of light. That's going to be nuts, right? And the challenges we all have to develop that is unbelievable. Okay, here we go. What are the costs involved to make a rocket ship? What materials do you use to make it? Sheesh, man. It's a great question. I think right now the cost to make a rocket ship, it definitely varies, but it's now it's billions, right? And I think it's really cool what SpaceX is doing. They've invested a lot of money in developing a rocket that a good portion of it can be reusable. There is cost with the fuel, right? There is cost in, like you talked about, the materials. There's some crazy materials that they're using now, exotic materials to make sure that it survives, right? It doesn't fatigue over time and it doesn't erode. Um, but there's also a big amount of the cost is in, but people don't appreciate this part. It's in the design. It's the number of people that it takes to develop the requirements and the concepts, to develop the design, to analyze it, then to build it, and then to test it multiple times so they have something that has a very good chance of surviving. So sometimes people talk about cost in terms of like the workforce, and then they talk about cost in terms of NRE or non-recurrent engineering. And sometimes they talk about in terms of materials. I think most of the cost is going to be in that initial design, development, and testing and integration and assembly. And then you're going to have some costs in the materials and operations. And then how long does it take for our production of spaceships to be completely made? Sheesh. I don't know. How long did SpaceX take? I think that concept they had been working on for about 10 years, um, maybe even longer before they had it. I know that working at NASA, different times we work with partners, we definitely worked on rocket ships for over 10 years before we finally had something that was functional. And the same goes for spacecraft. I've been working on the same spacecraft mission for like 2 years. So it takes some time. Great. Did you want to add anything to that, Betsy?
I think the only other thing I would add is that a lot of times the what you'll see is that you may create a particular rocket to do unmanned things, or even like with the Soyuz, they used it also like since the 70s. It's basically been the same design that they just keep iterating and making changes along the way. And so and making it better each iteration as they go. And so I think some of that happens too. It's kind of hard to like quantify that if you've been using something for 30 years and you've been, you know, incrementally increasing its capabilities.
Yes, good, good. Um, wow, what is your opinion of Space Force? What do you think?
I love both of these questions. So about the commercialization of space flights and about Space Force. So I think, you know, this is the future of our human space program. I am all for it. I think the more people we get involved in the commercialization, the more minds working on something. It just seems that when you start combining all these good minds, it's like you come up with something greater than, like bigger than itself. And so I am excited for our future.
Excellent. Yeah, I agree. I have a buddy, recent friend that just started that worked with Space Force. Yeah, and I think there's a, just like we have these ideas of we got to protect our country. I think maybe Space Force in some regards can help as we navigate how we share space and do things that are fair. There's some interesting stuff that happens in space because it's kind of like unregulated, right?
Right.
In that regard, I
Yeah.
think, if different entities around the world could come together, and I think Space Force helps in that regard, come together and let's try to make it fair and equitable in space for sure. And then what are your feelings about the commercialization of space? I think it's great. I think it's anytime you have some folks who come in with a new perspective and also desiring to make space and access to space very efficient. And, they're kind of competing to do it, so they have to, do it pretty well. I think there could be a benefit. So with Bezos, Branson, and Musk, all with their different efforts with commercialization at Telful and NASA, we work with them hand in hand. They come to us, they ask questions, we help them out. That's what NASA's all about, giving away that information freely to advance space in general. Um, what interested you in developing programs for youth in STEM education? I think we both could take this. Betsy's like the ultimate teacher, so I think she can take this as
Hmm.
well.
Oh, you
Just
know, I think it's all about kind of giving back. I think once you get to a certain part, you see the benefits of bringing people up with you.
Yeah.
And so for me, I always kind of had that vision for International Space Station. I wanted to be an astronaut, but I knew that I couldn't for some I had some spinal fusions and things like that, and but I knew I couldn't. And I wanted to be a part of it. I wanted to help people achieve that. I wanted to be a part of the space program no matter what. And so now I've kind of shifted to where I want to help other people find what they love and help them achieve those dreams. And so that's kind of what got me involved in STEM education. Like Milton, he has his nonprofit, which I think is awesome. For me, I kind of go at it from the academic areas where I'm helping, tutoring kids, and other students in various math and science areas too. And I just love it. I love to see when someone learn something new for the first time and that spark in their eyes as they're finding those new connections of what they can use it for.
Yeah. Same here. I mean, I feel like I've been so blessed. And sometimes I'm like, man, I don't even know if I deserved any of this, right? To be in this position. And I would love to give another student that opportunity. I want students to achieve much more than I ever was able to achieve for sure. And that's what it's all about. Like Betsy said, just giving back. Um, when first going into the field of aerospace engineering, did you expect to be where you are today?
Um, I would answer, no way. I would never have been able to predict where my career would take me. I never had the desire to even leave our country. And then I found myself working overseas and speaking a foreign language in order to help train our astronauts and cosmonauts. I think as you're going about your career, you're going to find areas that you love or you're good at. And as opportunities come up, you know, really decide for yourself which ones you think are going to be exciting or you think are the next cutting edge and focus on those. You don't have to say yes to everything. But for sure, when something comes your way, really consider it because like it was eye-opening for me to go overseas and to see how another, country does their space program and then to get to be a part of that. So, like I said, you just can't really predict where it's going to take you. But buckle up. It's an exciting ride.
Yeah, yeah, I agree with Betsy. I never anticipated. I think both of us had the opportunity to work for NASA. That was as a dream.
Hmm.
Never anticipated that for sure. And I think it's one of the reasons why we both want to get back to you all. Maybe we'll do a couple more. I think my video is maybe getting a little long. Uh,
Sure, sure.
what is the most valuable skill you possess to be successful in your field? I think a very important skill, is teamwork and being able to um, work with people of very different backgrounds who bring very different perspectives and just co-align on solving a problem for the good of everyone. And that's not easy. It's definitely not easy, but it's a very important skill. What do you think, Betsy?
Oh, for sure, teamwork, collaboration. I would say having an open mind,
Yeah,
uh, being able to see past what we've always done to see what things we could do differently or better.
excellent. All right. Let's see. Maybe this is a good page here. We'll pause here and maybe we'll do another video. How are all the different satellites and other objects in Earth tracked so they don't um run into each other? That is a great question. I probably should have researched that one first. Do you
I
have an
could
answer
I
for
could help you, yeah.
that?
So in my first job at Johnson Space Center, I was helping to train our flight controllers, two of them. One was the Attitude Determination and Control Officer, and the other we called Topo, the Trajectory Officer. So in that, the Topo is the one responsible for, making sure that our space station was safe, kind of the envelope or the cloud around it didn't have any debris or objects that might be coming into the area of space station. And if it did, that we would perform what we call a debris avoidance maneuver, where we could kind of reboost
Mhm,
the,
mhm.
or actually deboost in some cases to avoid whatever object it is.
Excellent. Um, what ideas are NASA and other organizations working on to mitigate? Oh, I think
That's
that's
you,
kind of
right?
right. Yeah, it just ties right in.
Yeah.
I know, but my
Uh,
satellite. Oh, go ahead. Go ahead.
oh no, I was just going to say, yeah, I think that part about having to do a debris avoidance if there's something coming near our space station is a great one, and we coordinate with the Russian ballistics officers if we have to do anything like that as well. But Milton has a really cool answer too, I think that goes along with this one.
Yeah, like we have a mission that's all around that's developing satellites that can help at some point even remove some of that space junk. But one nice thing about space agencies from across the world is they are doing a little bit better of coordination, right? And there has to be like they're trying to develop policies where part of the space junk is people will develop a satellite or a space vehicle, and maybe they didn't put as much thought into it. So it's a satellite that now is out there with a bad computer or something, and it's just floating. So there are some policies that most countries that are developing these vehicles are starting to buy into. And I bet we could send you some literature on that that ensures that we mitigate space junk and even things like, you know, um, not having a satellite out there that's out of control or limiting having satellites that have anything that will propel from that satellite that maybe could, hit another satellite is part of that. Maybe we'll end it here.